Imagine you click the run button on a program. Within 1 second, your CPU may execute billions of instructions. But how does the CPU understand what to do with each instruction? The answer is the instruction cycle. Every instruction a program runs goes through three important stages: fetch, decode, and execute. Today we'll explain how this cycle works and why it is important for CPU efficiency. Hello everyone, I am Riazuddin. My student ID is 25135 Now, first let's understand what an instruction is. An instruction is a command given to the CPU that tells it what operation to perform. For example, add R1, R2 means add values in register. Load A means load data from memory. Store B means store data to memory. Essentially, programs are sequence of instructions executed by the CPU. Now, the next part, instruction cycle overview, will be discussed by my next presenter. Thank you.
Instruction cycle. It is a very simple loop. Fetch, decode, execute are the three main stages. The CPU repeats this loop for the billions of time to run any programs. Now let's talk about fetch stage. First step, read program counter. The program counter holds the address of the next stage. Step 2, send address to memory. The CPU sends this address to the memory. Step 3, memory access. The memory finds the instruction at the location. Step 4, load instruction register. This instruction then stored in IR. IR means instruction register. Step 5, increments counter program counter. Automatically, the program counter moves to the next address. Step 6, ready for decode. Now the instruction is ready to understood in the next stage. And the
Next
next
stage is
stage,
decode stage. Here, control unit interprets instruction from the instruction register, identifies the operation that needs to be performed, and finds the register that needs to be that needs for the operation, locates the required data for the operation, and signals the ALU and other components for this operation. Here we can see add R1 and R2. Here, operation is add, and operand is register 1 and register 2. After decoding stage comes execution stage. In this stage, the actual operation is executed. ALU carries out mathematical and logical operations. CPU may also move data between register, access memory, or change the program flow using branch instruction. After the execution, the data is stored in the result is stored, and the CPU is prepared for the next execution.
Assalamualaikum everyone, my name is Isra Jahan Meme and my ID is 251352333. I am the student of the Decode International University and today my presentation topic is complete instruction cycle. Now I am describing about it. First of all, when we combine this stage, we get the complete instruction cycle. First, the CPU fetches the instruction from memory. Then it decodes the instruction to understand what action is required. Finally, we execute the instruction. After that, the program counter update the CPU begin again with the next instruction. And the loop continues million or billion of time every second. And then we can see our next slide. Impact of CPU efficiency. The speed of this instruction cycle directly affect the CPU efficiency. If the CPU can complete these stages faster, program will run faster. And importance factor that affect efficiency include CPU clock speed and cache memory and CPU architecture design. Optimizing this factor help reduce instruction cycle time and improve overall system performance. Thanks everyone.
Assalamualaikum everyone, this is Tasneem Subha. Thanks for mentioning. My ID number is 251355519. So today my presentation part is modern CPU optimization techniques. So there is several stages such as pipelining, superscalar, multi-core, branch prediction, out of order, and caching. So pipelining overlap instruction stages, so multiple instruction process simultaneously. Stage 2 is superscalar, so basically multiple execution units handle several instructions per clock cycle. Third stage is multi-core, multiple processor cores execute independent instruction streams in parallel. Fourth stage is branch prediction, so predict instruction flow to reduce pipeline stalls and delays. Out of order, execute instructions as resources become available, not strictly in order. And last but not the least, stage 6 caching, store frequently used data close to CPU for faster memory access. And last part, there is conclusion part, so there are different kind of steps. Number one step is fetch, retrieve instruction from memory using program counter. Decode, control unit interprets the instruction. Step 3, execute, ALU performs the operation and produces result. Step 4, faster CPU, efficient cycle execution improves processing speed. Step 5, better programs. So programs run faster with optimized instruction cycles. And last, step 6, efficiency. Overall computer performance is enhanced. That's it. This concludes my presentation. I welcome any questions. Thank you. Thank you very much.